Hello everyone, welcome back. So in this video, we are going to understand Leetcode problem number 3480, where we will do the maximize subarrays after removing one conflict array, right? One of the conflicting pairs we will remove, and after that we have to maximize the subarrays. Okay, means we have to count the subarrays, right? So let's understand what the question is saying, that we have given an integer n which represents an array nums, right? And it contains 1 to n. It means we have given this n, right? Means the element in this array will start from 1 to n, means 1 2 3 4, but the index will remain from where 0 1 2 3, right? Further, it is saying that additionally you are required, you are given a 2D array that is called conflicting pairs, where conflicting pairs contains like these two elements, means there will become conflict in the given arrays, right? So let's suppose for the conflicting pairs here we have two conflicts there, 2 3 and 1 4, right? Means here 2 and 3 is a conflicting pair. Okay, further it is saying that remove exactly one conflicting elements, right? Means we have to remove either this or this, you will decide. After that you have to count the number of non-empty subarray, means you have to create the subarrays from here, and that should not be empty, right? Which do not contains both a and b, that we will remove from, let's suppose we will remove 2 and 3, so 2 and 3 should not be there in the subarrays list. Okay, and those subarrays we will count and we'll try to find the maximize, we have to maximize that. So we have to return the maximum number of subarrays which is possible after removing exactly one pair. So you think you will remove this one or you will remove this one, but we need the maximum number of subarrays which is possible. I hope you understand. Let's understand through the slides. So we will have some visual to relate the intuition, and you can have the to-dos to implement the code before understanding or seeing the solution that I will provide. This solution will be best, right? And best approach will be there. And I hope you will understand. And definitely if you have any doubt in this video, please let me know in the comment section. But I will request you, please hit subscribe this channel, right? Give at least 20 to 30 likes minimum. I'm not requesting for 50 and 100, right? At least give 20 to 30 likes, because I'm seeing you are seeing 400 people are watching, right? And you're not giving one single like, right? So I'll suggest you to get better videos, right? You should also motivate me. Okay, so let's continue to understand through the slide. So as you can see here, right? So what we have given, think the first we have given is we have given n, right? So n is given 4. So the array is what? 1 2 3 4. Can we say that? We can say that. So what are the conflicting pairs we have? So conflicting pairs is 2 3 1 4. So we must remove exactly one conflicting pair, and then we'll count all the non-empty subarrays of nums that do not contain both elements from any remaining pairs. And what is our goal? Our goal is to maximize the total number of valid subarray, right? Once we will remove these pair, let's suppose 2 3 or either 1 4, then we have to count all the subarrays that we will form from this array, right? And we'll check these pairs should not be there. Either A means 2 should not be there, and B either means B is 3 should not be there. If you are removing this pair, means A is 1, 4 is B. So 1 4 should be not there, right? So we have to count those subarrays which are valid, right? And we have to return the total number of the valid subarrays, right? I hope you understand. You pause this, go through and understand what the question is saying that. Okay. So very first, let's understand some steps, right? So very first step, if all the possible subarrays of 1 to 3 will generate, let's suppose we'll go through index, right? Index will start from 0 0, means here will left and right will be at here, right? So only one what do you call element will be there, right? So very subarray is this, then we'll increase 0 to 1, we'll take from here to here, so we'll become 1 2, then 1 2 3, then 1 2 3, like this. If you see the index we have given written here, so you will understand here. Okay, this one is coming. Okay, let me cut it. So you understood the subarrays. So these are the subarrays we have given, and these are the indexes we have given, right? So these all are the possible subarrays that we can generate from 1 2 3 4 elements of the array nums. Can we say that? So as you can see, if you count this, you will get 10 subarrays, right? So we can generate all the non-empty subarrays like this, right? You will go by the index by index. When I is at 0, you can go all the j, then we'll increment the I again, then we'll go with all the j, right? And similarly, when we'll increase j, will also increase, where I will increase, and then j will also get increases, and we'll get all the subarrays. Means you know how to generate all the possible subarrays. Means we have to try with the all the possibilities, right? And you will generate the subarrays. I hope you understand the how to generate the subarray. We have given the index, you can understand, right? So this part you will see I, and this you say j, right? And I and j, from I and j you can take the substring, right? String dot substring you can take out from the array, you can take the 0 to 1. That will understand later. Just think that how to implement, how to generate that. So these are the subarrays, right? And you can get the all the subarrays, right? So there will be 10 subarrays. Can we say that? So as expected, the formula can be take n into n plus 1 by 2, right? So n here is 4, 4 into 5 n plus 1, and we'll divide 2, so it will come 10. So total subarrays is 10. I hope you understand. Mathematically we can also say 10, and you can see all the possible subarrays is also like this. Understand? Now understand the conflicting pairs. So we are given two conflicting pairs. The very first is 2 3, and then we have 1 4. When we are taking 2 3, means subarray cannot include 2 and 3 both, A or B, right? Remember the question was saying A and B. So if a pair contains A and B, these A and B both should not be in the subarrays. Okay. Similarly, if we are having this pair, another pair 1 4, it should not having in the subarrays. So we can remove only one of these two pair. We will not remove both of them. If we'll remove both of them, nothing will be stay there, right? So what we will do, we'll say these are the conflicting pairs, out of which remove only one of these two pairs. Either you will remove 2 3 or 1 4, right? So there will be two scenarios, right? Either you will remove when you remove these 2 3, and when you remove 1 4. So can we say we will check two scenarios. The very first scenario is that when we remove 2 3, what will happen? The remaining conflict is 1 4. Can we say that? So the subarray cannot include 1 4, correct? Because this is a conflict. So we will not include 1 4. In where? In the subarrays. So let's filter the subarrays that includes 1 4. Correct? So from 1 2 3 4 includes 1 4 will be invalid, right? And all other fine. Correct? Means total subarray is what? 9. Right? So we'll keep 1 2 3 3 4 4 1 2 2 3 and 1 2 3 4 1 2 3, right? So these are the total 9 what you call valid subarray. Let's understand another scenario where we'll take 1 4. So remaining conflict is 2 3, right? So the subarrays cannot include what? These 2 and 3. So let's remove the subarray that contains 2 and 3. So if we'll remove, it contains what? 1 2 3 contains 2 and 3, it is invalid. 1 2 3 4 contains, it's invalid. We'll take 2 3, it's also invalid. 2 3 4 invalid. So invalid subarrays are 4. So 10 minus 4 is 6. You are getting 6. So previously for the first scenario, what you have got? You got 9. But for this scenario, you are getting what? 6. So can we say that when we are removing 2 3, it gives 9 valid subarray. When removing 1 4 conflict, we are getting 6 valid subarray. So the answer is we have to maximize. So we'll remove the 2 3, so that answer will be maximum. I hope you understand, right? So if you summarize this, you can understand which one is valid, which one is not valid, right? So when 2 3 contains, you can visualize that this is contains, yes, this is contains, this is contains, and this is contains, and rest of the not contains. Similarly, when on 1 4 we are checking, we are seeing this one, right? So when if we are valid, if remove 2 3, we are getting all these 9s, right? We are not only having at 1 2 3 4, right? But the rest of thing is coming. When we are removing 1 4, we are seeing that these 4 are not valid, right? Rest of the thing are valid. Understand? So if we summarize the total subarray n into n plus 1 by 2, you will try removing each conflicting pairs, right? First of all, count the total subarrays, right? You know, if n is 10, recall 4 into 4 plus 1 by 2 means 10, it will come. Then we'll try removing each conflicting pairs. There will be two scenarios that you can try by removing, and you can count how many subarrays are valid. If the pair is removed, right, you have to find the maximum count over all the possibilities, so you have to track the count. Understand? So the, if we'll say the problem was what we have given, array we have given, let's suppose we'll say 1 2 3 to n, and the list of conflicting pairs are conflicting pairs where we have each pair we have, let's suppose contain a and b. It means a subarray is invalid if it contains a and b, right? So we are allowed to remove exactly one conflicting pair, right? So what is our task? We have to count the maximum number of valid subarray, right, which is possible after removing one conflicting pair. I hope you understand, right? So let's understand the intuition. So without any conflicting pair, the total number of non-empty subarray is in the size of what? N into n plus 1 by 2, right? With a conflicting pair, some subarray will become invalid if they contains both n, a, b from the given pairs, right? So the goal is we have to remove one conflicting pair, and then we will count how many subarrays are valid now, and then we'll maximize that number. So you know how to do that. You can go through the steps. Various first step, we have given n, you have given conflicting pair, we'll get all the subarrays, right? We have seen that total subarray contains like this, right? Length, you can check the length of this each one, and the conflicting pair, we have two conflicting pairs. We have seen that if it contain, we have to eliminate if both having contain 2 and 3 or 1 or 4. So these conflicts you have to check, and you know how we are getting the valid one. So you can check the valid is coming 6 or coming 9, right? And that you can understand. Further, you will try removing one conflicting pair at a time, right? And you will see what are the values we have and what are not the values here. Either you will get 6 or you will get 9, right? Removing. So best, you know that we will get the best at what? When we're removing 2, 3, right? So the final approach is we will convert all the conflicting pairs into map, right? For each you know the conflicting pair, right? So we'll convert all the conflicting pair into map, right? And for each a will store smallest value of b that contains that it conflicts with, to help the prefix bonding. I will understand, so show you how the bounding will contains, right? So we'll iterate from left to right, and we'll maintain the left boundary of the conflict of every possible. So you'll use to calculate how many sub problem ending at the index, and then we'll use a array, right? And we'll keep track of how many subarrays are invalid, okay? And then we'll go with the sum of total valid subarray. We'll keep moving for each conflict, and we'll pick the best outcome. So let's understand what the complexity will come, where we are having the conflicting pairs. We have, let's suppose, m size, right? So total we can say n plus m, right? We'll go with the scenario, and this makes you the best approach here. So very first step, let's understand the how we are going to write the code, right? So we have the max sub arrays, right, as a given function we have given, where we have n and conflicting pairs we have given in an argument, and we have returned the long, right? We have to maximize the number, right? Return count, you can say. Very first step, initialize the helper array for storing a smallest and the second smallest conflicting pairs, right? Then we'll populate these two variables from the conflicting pairs, and will initialize value for the main sweep. So the sweep from the right to left will go from n-1 to the computing subarray contributions, right? And will track the conflicting boundaries. We'll show you how to do that. Then further, there will, in the, when we are sweeping the value, right, there will be a, b and c, right? These are the steps we will need to do, where first we will track the minimum conflict, then we'll add the valid subarray starting at I, and if we will remove the top conflict, right, we'll find how many subarrays do we unlock, right? After each swap, we'll choose the best conflict to remove the max again, and we'll return the final result. Okay, let me show you in the details. Very first step, what we have understand, very first step, we have to initialize the helper array for storing a smallest and second smallest possible values. Let's call it b min at 1, right, where this b min is nothing but the smallest b such that I to b, right? And it conflicts pair between I should be less than b, correct? Similarly, we'll have the b min 2. Okay, so these two will define the smallest b, right? And a smallest, second smallest b, we can say. Okay, for the b, and then we will define the max value of these two. We will fill with the max value. Then we will populate the these two value from the conflict. How we are going to do? We'll iterate over the conflicting pairs. We'll get one conflicting pair at a time, and we'll get a and b. So this is the pair at 0. Pair at 0 will get, right? So pair at 1, which one is the minimum, will go into a. Which one is the maximum, it will go into the b, right? Then we'll check if the b min at a, if it is greater than b, will update b min 2 at a is the value of this, means we are doing swapping. And then b min at 1 will update back to this one, means what we are trying to do here, for each a and b, let's suppose we have a and b, right? First we will check what, where a and a is less than b, obviously, right? That is a pair, right? So we have to keep track of what, so b at min a means the smallest b that conflicts with a, right? And b min at 2 means the second smallest b that conflicts with a, right? Which is used for removing the smallest conflict letter, right? So for each a and b, right, what we need to do, we know that if there is a what you call, we have a and b, right? So we have to find a should be less than b, right? And then we'll keep track of what, this b min a, 1 a, and this b min 2, right? So this is our second smallest, smallest and second smallest, can we say that? So that we'll keep track of this smallest and second smallest, right? So that when we are removing from the conflict, we'll keep updating each time here. Okay, like this. So we'll see, we'll update if it is greater than b, we'll update like this. Now understand, we will initialize the value from the remaining swipe, right? So this is our main swipe. So how we are going to do, first we'll initialize a result, right? So it will count the valid subarray with all the conflicts we have, right? So we'll try and we'll update our count. Then we have ib1, means it's an index with the current global smallest conflict, right? And this is the second best blocking index for backup removal, and we'll use array that is called delete count, right? Where we'll have same length n plus 1, and it will gain in the subarray count if removing is top conflict. Then what we need to do, we have to swap from right to left, from it will start from I n minus 1 to compute the subarray contribution. So for example, if int I is equal to, and we'll go to greater than equal to 1, right? And I minus, we have will update these three steps we need to do. Step 1, we'll track the minimum conflict boundaries. Then step B, we'll add the valid subarray starting at I. So it will go up to conflict, and then we'll go with, if we remove the top conflict at this one, so how many subarrays do we unlock? So very first, when we are swapping from right to left, right, means we have to make a loop from where, I n to 1, right? Means we have to do, in this swapping, we have to track these three steps, right? Tracking the minimum conflict boundaries, then we'll add the valid subarray, and then if we remove the top conflict, right, then we have to check how many subarrays we do unlock. Then we'll track the, let's suppose in the steps, in the when we are making the for loop, we'll check this step, right? Very first we'll check this, if b min at 1, right, at ib1 index for b1, if it is greater than b min 1 at y, means we have to update the second conflict, means b2. How? We'll check the minimum one, which is the minimum one, that will store. Then we'll do what, ib1 equal to I, means we will update the current I has a better, a smallest conflict, right? So we'll update it, right? Then we'll try the else condition, right? So we'll update the second smallest boundaries. How? We'll just take the minimum value, we'll store in the b2, right? Like this we will update our minimum conflict boundaries first. Then we have to add the subarrays starting at I, right? So for that we'll take the mean of this ib1, index b1, right, and n plus 1, and we'll do -1. So we'll keep updating res. So what we are doing here, we are doing subarray starting at I right here, and are valid only up to the conflict boundary. So if the b mean at 1, ib at 1, right, is equal to z, then we can form a subarray I plus 1, and j minus 1. Understand? So in the last step, in the C, in the loop, in the for loop, what we will do, we'll remove top conflicts, right, and we'll check how many more subarrays do we unlock, right? So for that we'll delete the IV1, right, and we'll provide the mean and mean of mean, right? We'll take an n plus 1 and we'll use this formula, right? So we will remove the primary conflict at IB1, and the next blocking pointer becomes what? Either will be mean at this one, or will global b2 will have from the another elements, and then we'll delete, we'll use the delete at this. It will hold how many more subarrays would become valid. If we'll remove the valid one, then we'll we'll keep storing, we'll updating the delete count. In the last, we'll swap after the, we'll choose the conflict, right, and for that we'll go with the delete count and we'll find our max. What is the max? So among all the I, we'll choose one with the best gain from the conflict removal, and finally we'll return the final result like this. Okay, so to summarize this, what we can do, we'll track the top conflict for using the b min 1 and b min 2, right? You know that. What is this? So we'll take swap right to left and we'll track how many subarrays are valid if no conflict removed, and we'll remove we'll swap also how many extra subarray we had gain if we remove the top conflicts for some a, right, and then we'll choose the conflict removal that gives the maximum gain, and that will return as a total valid plus max gain. So let's understand the code. So very first step, what I told you, you just go and initialize these things, right, and then for all the conflicts you will get what? You will get the a and b, then you will update the b min 1 and b min 2, right, will update. Similarly for the final step, right, what you need to just define these required things like result b1 ib1 b2, right, we'll define it, and then for this loop, right, we'll make a swap, right, we'll start from the n to 1, right, like that, and you will update our result and the delete count, right, and you will update the delete count. Once you update the delete count, you just need to make a for loop, and right, you will find the max and you will return this result plus max. I hope you understand. If you have any doubt, let me know in the comment section. I'll also create another video where we'll do dry run. Thank you guys, thank you for watching this video, and let me know in the comment section if you need any help. Thank you for watching this video.